Poland tests Norwegian acoustic drone detector. Poland is testing the counter-drone technologies it intends to deploy along its eastern border, and one of the systems that showed up at the Central Air Force firing range in Ustka last week listens for drones rather than looking for them. Operational tests for Poland's Eastern Shield program, known in Polish as Tarcza Wyshot, have been running at the Ustka range on the Baltic coast, with 7 acoustic drone detection systems undergoing evaluation as of April 22, 2026. Among the systems tested was the Discovair G2, developed by Norwegian firm Squarehead technology, distributed in Poland by Forceful SPZOO, an acoustic sensor built around an array of directional microphones that detects, tracks, and classifies drones by analyzing their sound signatures rather than their radio frequency emissions or radar cross-section. Cezary Tomczyk, Poland's Secretary of State at the Ministry of National Defense, visited the tests on April 22 and used the occasion to articulate the scale of Poland's counter-drone investment: 25 billion zloty, 686 billion allocated in 2026 alone for drone and anti-drone system procurement drawn from the state budget and the European Union's SAFE program. The acoustic detection approach that the Discovair G2 represents addresses a gap that Polish military planners and their counterparts across NATO have been grappling with as drone warfare has evolved. Conventional counter-UAS sensors rely primarily on radio frequency detection, which identifies the control signals between a drone and its operator, and radar, which detects the physical presence of an airborne object. Both approaches have limitations that adversaries have learned to exploit. A drone modified to eliminate RF emissions operating on a pre-programmed flight path without active communication produces no signal for an RF detector to find in terrain with radar shadow or significant ground clutter. Small, low-flying drones can move through gaps in radar coverage undetected. An acoustic sensor that detects the sound the drone's motors and rotors produce, sound that cannot be switched off or hacked away, closes both of those gaps simultaneously. Squarehead technology describes the operational logic precisely. No drone can be hacked. To silence the acoustic signature of a drone in flight is a physical consequence of its propulsion system present, regardless of what software runs on the vehicle or what electronic modifications have been made. The Discovair G2 uses directional microphone arrays and AI-assisted signal analysis to identify drone sound signatures, even in acoustically cluttered environments, the ambient noise of wind, vehicles, and human activity that would defeat a simpler listening system. The result is a passive sensor that produces no emissions of its own, making it undetectable to drone operators scanning for the electronic signatures of active counter-drone systems. The passive characteristic is operationally significant in ways that extend beyond simple concealment. An RF jammer or an active radar announces its presence to any adversary equipped to detect it, potentially enabling enemy drone operators to route around the system or delay until the defender reveals its disposition. A passive acoustic array that simply listens generates no detectable signature. The drone flies toward it, produces the sound that triggers detection, and the defender knows the drone is coming without having disclosed the existence or position of the sensor. The Ustka tests are part of a broader evaluation pipeline that Poland's Ministry of National Defense Innovation Department initiated in early 2025. The program has received more than 715 submissions of innovative technologies across sensor systems, autonomous platforms, engineering and military logistics, communications, and cybersecurity from universities, startups, large companies, and foreign entities. Of those submissions, 36 solutions have already been tested under conditions approximating real combat operations. The acoustic detection tests currently underway represent one slice of that evaluation effort. Earlier in April, from the 13th through the 17th, 8 electronic warfare systems were tested at the same Ustka range, covering detection and jamming capabilities against drone signals. Tomczyk was direct about the strategic logic of developing these capabilities domestically rather than simply purchasing them off foreign shelves. It is easy to buy abroad. There are technologies in the United States and Korea that can be bought off the shelf, but that will never be entirely what the Polish army needs. He added that if the technology resides in Poland, if the Ministry of National Defense or Polish state-controlled companies own the specific technologies, no one can take them from us. Jen Marchingorka, director of the M&D Innovation Department, confirmed that solutions best matching Polish armed forces requirements will support Eastern Shield. Dr. Mariusz Sieja, head of the Autonomous Systems Center, stated his particular interest in identifying solutions that could be deployed by the Polish armed forces in the future. The Eastern Shield program is Poland's comprehensive national security initiative covering both infrastructure development and technology integration along its eastern border, the frontier with Belarus, and the Russian exclave of Kaliningrad that has become one of NATO's most strategically sensitive land boundaries. The program engages a broad range of public institutions and industrial partners while building public awareness of defense requirements.